What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are tackling some more SAT 2 math, which a lot of people have been requesting. So I'm really excited to finally get back to it. Last week we had a full week of just straight up SAT math in preparation for the August SAT, but now we are back on track. So here we go. We got the audio check going. We're ready to rock. And I got the calculator queued up. This is a 60-minute test. I'm going to just jump right into it. And we got an hour queued up on the timer. Again, I haven't seen these problems, so I'm doing them all for the first time. And this is a test where I'm not as familiar as I am with the SAT math, so just bear with me, but I'm going to do my best, knock it out. I think last time I wasn't able to do it in the hour, so I just spent extra time and finished it off. So if I have to do that today, I'll do it today. And anything that I get wrong, once I check it, I will explain it, and we'll go through it at the end. So make sure to post your questions. I won't be able to get to them right away, but I will try my best to get to them at the end or later on if you leave them in the comment section. If you like this video and are enjoying what I'm doing and is providing you value, please click that like button. It really helps out me as well as the channel. Here we go. We're going to start in 3. So again, I'm taking it in real time without preparation and trying to solve everything live on camera to give you the best advice and real-time strategies. Here we go. 3, 2, 1. Let's do it. 3x plus blah, 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 then k equals. Okay, these two sides are equal, so I'm going to multiply across. I'm going to say 3x plus 6 equals kx over 4 plus 2k over 4. Very simply, I can see that these two quantities have to be equal. So do these, but let's just go with this. So 6 equals, because we're trying to solve for k, 6 equals 2k over 4. Multiply both sides by 4. 24 equals 2k, k divided by 2, k equals 12. Let me just make sure. Is that 12? I'm sorry, that's 12. That would be 3. It'd be 3x and 6. Yeah, it works. Okay, next. The relationship between reading C on the Celsius temperature scale and reading F on the Fahrenheit. Okay, the relationship between reading on the Celsius scale and K and the okay. Which of the following expresses the relationship between reading on Kelvin and Fahrenheit? So we're setting Kelvin. So again, C plus 273 is Kelvin. And so if I took K minus 273 equals Celsius, and I took that and I just plugged it in for the C there, it'd be K minus 273 equals 5/9 times F minus 32. So that would be the answer. And they've isolated K, so I just add 273 to this side. So it's just this plus 273. And then it is which one? 5/9 F minus 32 plus this one. I think that's it. 32. Yep. Okay, what is the slope of the line containing these points? Okay, stack the anytime we solve slope, we stack the coordinates and subtract down. It's the y's minus the y's over the x minus the x's. Just subtract down. That turns into a plus. This is 6 over 5, which is 1.2. We could use a calculator, but I happen to know that. Oh, one of my lights just went out. All right, next. What is the slope of the line containing the points 3, 11? Oh, no. Oh, shoot. Why did that light go out? All right, we'll figure that out later. X plus y equals 2. Hold on. Let me just do this light as a backup. Okay, just to balance out the lighting a little bit. All right, next, if x plus y equals 2, y plus z equals that, x plus y plus z equals 10. So x plus y equals 2 and y plus z. So I'll replace x plus y with 2 plus z equals 10. So z equals 8. If z equals 8, then y equals negative 3. Negative 3 plus 8, negative 3, and then x equals 5. And then x equals 5. 5 plus 8 is 13. Yeah, it works. All right, number 5. If f of x equals this and g of x equals that, then okay. So we're plugging and chugging. So basically, first I'm plugging 5 in for this. So this becomes e to the 5th. And then I'm plugging, right? And then I take this and I plug it into this x. So now we're taking f of that value. So it's 3 ln of e to the fifth. And ln of e is just 1. ln of e to the fifth, it's just whatever that exponent is. So it's just basically ln of e to the 5 is just 5. So it's 3 times 5, which is 50. Oh, wait, I don't see that answer. Oh, minus 1, which is 14. I didn't catch that guy. So it is 14. You can use a calculator if you want. You don't need to just like know these exponent rules. It's a calculator test. So that is also in your back pocket if you need it. The intersection of a cube with a plane could create which of the following? Obviously a square, because I would like to say check mark. It could do a parallelogram if it slices it like this way. Okay, because then you'd have like this. It would be like that. Okay, so you could have a parallelogram, and you can have a triangle too. Here, I'll show you. You can have. Oh, whoops. Let me say square parallelogram. You can have a triangle if you have a plane that cuts it like this, cuts like a corner, and then you'd get a triangle. If that makes sense. So I'm gonna say 1, 2, and 3. The figure above shows a rocket taking off vertically. When the rocket reaches a height of 12 kilometers, then the angles of elevation points A and B on level ground are 84 points, 60 points respectively. What is the distance between points A and B? Got it. Okay, so I'm going to do this. I'm going to create a line straight down, and I'm going to say these are two right triangles, boom and boom. And then let's just pretend it's kind of going like this, whatever. It's not perfect. I'm not going to scroll up and make it exact. So this is 90, this is 90, and then we got these two right triangles, and this is a height of 12. And then we want to know, basically, I need to know this distance, and I need to know this distance. So what we can do is I can say, we're going to use tangent for both, opposite over adjacent. So tangent of 62.7 equals opposite, which is 12, over adjacent, which is this value, and I'll call this one y. And then this, and then eventually we're going to say x plus y. And then this one is tangent of 84.1 equals opposite, which is 12 over y. Okay, and then basically all I'm going to do is multiply both sides by y, divide by tangent of 84.1. So y equals 12 over tangent 84.1. X equals 12 over tangent of 62.7. 12 over by tangent, where is it? Where is tangent of 62.7, right? Equals that, plus 12 divided by tangent of 84.1. 1, 2, 3. So it looks like it's 7.433. Feels good to me. All right, let's keep going. Next, what is the value of x squared if that equals that? Okay, let's just square both. Oh, this is simple actually. This becomes 225 minus 144. What am I doing? Minus, that's 1, 8. So it's 81. So x equals square root of 81. Square both sides, and x equals 81. Or x squared equals 81. Sorry. Done. All right. Let me just make sure that's right. 225 minus 144. 81. Okay, I think it's good. The points of a rectangular coordinate plane are transformed in such a way that each point is moved to this. So if the distance between point P and the origin is D, then the distance between P and the the origin is what? Okay, let's just do it. I'm just gonna plug in values, to be honest. Wait, hold on. Can I figure this out another way? So that distance is square root of x squared plus y squared, okay? Because it's to the origin. So here's the origin at 0, 0. Here's x, y, right? So the distance is this far. It's like a Pythagorean theorem. This distance out is x, this distance up is y. So the total distance is x squared plus y squared, and then the square root of that, right? This one is the square root of 2x squared, plus 2y squared. Okay, so then now let's see if I can, wait a minute. Oh, I know what I can do. So then this one becomes square root of 4x squared plus 4y squared, which I can factor out of 4x squared plus y squared. And then square root of 4 is 2. So this second one becomes 2 times... So it's literally double the distance. So it's 2d. It seems so obvious, which is why I'm skeptical, or I would have been skeptical. It seems too obvious. But I just did the math, and I think that works. So I'm feeling fine. If f of g of x equals this, and f of x equals this, then g of x equals. Okay, so basically so if this is f of x, and then I'm plugging in for x, this is g of x right here. Square root of x squared plus 1, because all they're doing is they're taking some function and they're replacing x with it. And look, they've replaced x with this function down here. So g of x has to just be square root of x squared plus 1. Simple. Okay, that's just straight up function notation. Next, 11. If a is the degree measure of acute angle and sine a is 0.8, cosine of 90 minus a is the same thing as 0.8. This is a basic rule they test all the time. Sine of a is equal to cosine of 90 minus a and vice versa. The set of points x, y, z such as blank is... I think this is a sphere. I can't remember for sure why. I know a circle is x squared plus y squared equals 1, so I think like a sphere is the same thing. It's just now we add a third dimension. I'm pretty sure that's it. The graph of the rational function f, where this has a vertical asymptote. Okay, vertical asymptote is where the denominator goes to 0, so I'm going to factor. And I've got x minus... Wait a minute. It doesn't factor. 8 and 2. 4 and 4. X minus 4. X minus 4. And then the vertical asymptote is x equals 4. 4 only. No 0. No, I don't know where they get the 5 from. Oh, 5 maybe. I don't even know what the 5 does. But yeah, the vertical asymptotes are where this goes to 0. Since it's a perfect square, it's only where x equals 4. Okay, next is number 14. Graph of blank, 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 blank is shown above. Which of the following could be the value of c? Negative 80. Oh, negative 72. It's just the y-intercept. If x is 0, all this cancels out, and then it'd just be that c value, which is negative 72. Cosine of x equals that. Secant of x is... Secant is 1 over cosine of x, so 1 over 0.4697. 0.4697. 2.129. That's it. Okay, 16. The club is planning a trip to a museum that has an admission price of 7 per person. The club members going on the trip must share the $200 cost of a bus and the admission price for 2 chaperones who will accompany them on the trip. Which is the following correctly expresses the cost in dollars for each club member as a function of n. I did it as x, but whatever. As a function of n for it would be all of this divided by the people that are there. So if I want to reduce this, it's 7x or n, whatever, over 240 over x. So it's 7n plus 214 over n. It's this one. That's what I do now a lot of times. I already can tell. I'm like, hey, I should probably set up some sort of an equation or something, or expression, and I just roll with it, even though it's not perfect. Which is fine as an equation whose graph is a set of all points equidistant from point 0, 0, and the set of points. Oh, this is crazy. I get it. All right, so 0, 0 is here. 0, 4 is here. And so it would be right in here. It'd be x equals 2. It has to be vertical like this. It can't be straight like that. And then it's always equidistant every point. You see? Or here. So it's x equals 2. What is the sum of the infinite geometric series? Ooh, I can't remember this. Wait. I don't remember the formula for the sum of a geometric series. I know it has a sum. 2 squared, cubed, to the 4th, to the 5th. Every time it's like multiplying by 1/2. Darn it, I can't remember the formula. I can probably deduce this though. Hold on. I have a song on this and I'm blanking on it. It's like A1. It's like 1 minus A1, or A1 minus 1. I can't remember. All right, I'm going to have to improv. So I'm going to do 1/4 plus 1/8 plus 1/16. 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1/128 plus 1/256 plus 1/512 plus 1/1024. So that should be pretty good. That should be enough. So it looks like it's approaching a half. Right? And then if I added, watch, I mean, you can see, plus 1/2048 would be the next one. Still doesn't pass a half. It's got to be approaching a half. Okay, that's my workaround solution. Like I said, there's a formula for this, but I just can't remember it. Which of the following is equivalent to this? Let's add s to both sides. P plus 2s is greater than p. Subtract p from both sides. 2s is greater than 0. Divide by 2. Divide by 2. S is greater than 0. That's it. If a and b are in the domain of a function f, and f of a is less than f of b, which of the following must be true? This makes no sense at all. This doesn't necessarily make any sense either, because I could say that it could be f of x could be x squared, and then I could say that I could say that like a is -10 and b is 1, and f of a, wait, I did that backwards. I could say b is -10 and a is 1, and then b is smaller than a. I mean, so look, this can't be true either, because I could do the flip. I'd say this is true. This is the only one that's true, because if it's a function, you can't have the same x value give you two different y values, and that's what that would be saying. So that one has to be true, that they cannot be equal. In a recent survey, it was reported that 75% of the population of a certain state live within 10 miles of its largest city. Within 10 miles. And that 40% of these single. So, hold on, let me do that. 0.4 times. What? I did divide. 0.4 times point equals 0.3. So this is, I'm going to change this to 30% of the total. So this is like no longer 40% of this, is just 30% single family house. If a resident in the state is selected at random, what is the probability that the person lives in a single it's 30%. I already did it. Let's do a better circle. Which is the same as 0.3 probability, same as the decimal. To the nearest degree, what is the measure of the smallest angle in a right triangle with sides? 3, 4, 5. So 3, 4, boom, boom, and they want this angle. Because the smallest angle is opposite the smallest side. So we can get it by saying tangent of theta, just arbitrarily choosing tangent, equals opposite over adjacent 3/4, and then take arctangent of both sides. Inverse tangent of 3/4, and that will give me my answer. Okay, inverse tangent of, I'll just say 0.75. It's 37 degrees. Rounded up. Okay, almost at the halfway point. Next, which of the following is an equation of a line perpendicular? Okay, it just has to have a slope of negative reciprocal of this, which is 1/2. So y equals 1/2 x plus whatever. It doesn't matter. Y equals 1/2 x. It's this one. Yeah, these are all no good. Yeah, this doesn't even make sense. Yeah, it's that one. 24. We're not doing great on time. We're doing okay. What is the range of the function f where f of x equals... Okay, so normally I could actually just graph this because we're allowed to use a graphing calculator, but I can figure it out. Normally the range is -1 to 1. By that, it's -3 to 3, and then the -4 shifts everything down by 4. So it's -7 to -1. Of the following list of numbers, which has the smallest standard deviation? AKA, which one is the most tightly packed? That one. Don't have to calculate standard deviation, but I know that's basically like the tightest you can get if they're all the same. Okay, we're past half a point. Formula A equals blank, blank, blank. So savings account will be worth after an initial investment. Okay, whatever. How many years will it take, which is T? How many years will it take an initial investment of 1,000 be worth 5,000? So we got 5,000 equals 1,000 e to the 0.08, and we're solving for t divided by 1,000. 5 equals e to the 0.08 t. Take natural log of both sides. Natural log of this side just becomes, the exponent basically just comes down, and we lose the ln and the e, equals ln over 5, divide by 0.08, divide by 0.08, and we'll get our answer. Ln of 5 equals divided by 20 years, 20.1 years. Approximately 5,000. Boom, 20. You could have plugged in chug 2 if you didn't know how to do this. You could have just like plugged in values. If sine of theta is greater than 0 and sine theta, cosine theta is less than 0, then theta must be in which quadrant? Oh, hold on. So sine is positive, which means it's either quadrant 1 or 2. So it's not 3 or 4. 3, 4. And then sine times cosine is negative. So sine is positive and cosine has to be negative because obviously it's a positive times positive, positive. Positive times a negative is negative. Cosine is negative. Cosine relates to x. So cosine is negative only in quadrant 2 and 3, but 3 is already out. So it's got to be quadrant 2. Okay. Well, now we're really at the halfway point in terms of the pages. Here, let's zoom out. 1, 2, 3. Okay. If f of negative x equals f of x for all real numbers x, and if 3, 8 is a point on the graph of f, which following points must also be on the graph of f. Hold on. Oh, I got it. It's the same. So then if I plug in a negative x, I get the same as if I were to plug in a positive x. So it'd be -3, 8. That's all this is saying. Hey, you plug in a negative x, you're going to get the same y values if you had a positive x. So they had said +3 is 8, then -3 has to equal 8. If x equals y, then x squared equals y squared. If x and y are real numbers, which the following cannot be inferred from the statement above. Hold on. Remember, x squared equals y squared is sufficient that x... That can be inferred. A necessary condition for x to be equal to y is that I guess that's also true. X is equal to y implies that B is my only suspicious one. Hold on. It is sufficient. I think that's good too. If x squared is not equal to y squared, that's the contrapositive. That's also true. X squared is equal to y squared. This is not. This is the, what is it? It's not the it's the inverse. No, it's the converse. If A then B then B then they're saying if B then A. And I can disprove this too because that could be x could be -2, y could be 2. If x is then x is equal to y. It's just not a true statement. So that's another way to figure out that that's wrong. In how many different orders can 9 students arrange themselves in a straight line? It's 9 factorial, whatever that is. Okay, because, hey, this person, with the first spot, we can have 9 options. And once we choose that first spot, it's got to be 8, then 7, then 6. And we go all the way down, which is literally 9 factorial, which is this exclamation mark. And again, you have your calculator, so 336, this one, right? 360,880. All right. Next. What value does ln of x over x minus 1 approach as x approaches 1? I don't know, but I'm going to graph it in Desmos. That's what you should use your graphing calculator for. Maybe there's a better way to do this or a non-graphing calculator way, but I don't know and I don't care. Y equals ln of x over x minus 1. A now. So it says as x approaches 1. Okay, let's see. Oh, it approaches 1. And see, it's undefined there because obviously it goes 0, but it approaches 1. It does approach a unique value. Come on now. All right, next, if f of x equals, it doesn't say what does it equal. It says what does it approach, right? As x approaches 1. F of x equals 5 minus 3x. Then f of 2, this is just plug and chug. I'm just going to plug, oh no, never mind, hold on. So I will plug and chug. So if f of 2, so that's 5 minus 3 times 2, which is 5 minus 6, which is negative 1. Absolute value of that is 1. So which one of these also gives me 1? Not this one. Not that one. That gives me 8. This one gives me 2. This one gives me 1. Because 4/3 times that is 4. 5 minus 4 is 4. 5 minus 4 is 1. Absolute value of that is 1. This one would give me 2 also. Let me just make sure. Negative 6, yeah. What is the period of the graph? Okay, so it's normally 2 pi. I can't. It's 2/3. It's whatever the, no, sorry, wait a minute. Whoa. Tangent has a period of pi, not 2 pi. So it's 1/3. It's the regular period divided by whatever this value is. And then I would always check it because I want to make sure I'm not making any mistakes. 2 tangent. The 2 doesn't matter. That just extends the range. 2 tangent times 3 pi x. What was it? And then plus 4. Again, the plus 4 doesn't matter either, really, but we'll just put everything in. Okay, so look, we can see from here to here, that's clearly a period, right? So it's 0.2423, 0.5756. 0.5756 minus 0.2423. And there it is. It's 1/3. Okay. Next is this one. North Road, that one. The figure above shows a car that has broken down on East Road. A tow truck leaves a garage on North Road at point A. A tow truck leaves a garage on North Road at point B. The straight line distance between A and B is 50 miles. Hold on, let me draw that in. So they say that's 50. If the tow truck travels at an average speed of 45 miles per hour, so the tow truck's here. How long will it take the tow truck to get to the car? Oh, and that's 20. Oh, okay. Now we can. I didn't see that. So we can use Pythagorean theorem to find this. So it's 20 squared plus x squared equals 50 squared. 20 squared is 400 plus x squared equals 2500 minus that. X squared equals 2100. Square root. 2100. 45.83, I'll say. 45.826. Okay, and then it's going 65.826. And it's going 45 miles per hour. So it's 65.826 divided by 45. 1.4628. Now multiply that by 60 because I saw the minutes. So it's 87.768 minutes. I'll say 88 minutes. So if it's 88 minutes, that's an hour and 28 minutes, right? Because 60 minutes is an hour. And so that looks good to me. As long as I did those calculations right, I think I'm good. I think it's all good. I'm not going to double check. But I would, on the real test, I would have done that all on a calculator just to be safe. If f is a polynomial of degree 3, 4 of whose values are shown in the table above, f of x could equal. Okay. So I know we got a 0 here. So I know it's got to be x plus 1. It's got a degree 3. It's got another 0 at 2, so it's going to be times x minus 2. So this doesn't have an x minus 2. That's out. This has x minus 2 and x plus 1. This doesn't have an x minus 2. X minus 2, x plus 1. Okay, so I've at least eliminated there. And then I know that when x equals 0, it's got to equal 1. Okay, so if I 0 this out, 1, -2, that's 1, that's okay. 1 times -2 times -1 is 2. That's out. You see I'm like plugging in the values in my head because I see that when x equals 0, it's got to equal 1. This one's out too because this would be 2 times 1, which is 2, times -2 is -4, so it's b. Oops. The only prime factors of a number n are 2, 5, 7, and 17. Which of the following could not be a factor of n? Well, 10 would be a factor because if 2 and 5 and the number is 10, 70. The number is obviously this. If it's saying the only prime factors, well, at least that. It could be more, right? Because it could have multiple 2s, multiple 5s, I don't know. But at a minimum, it's got to be this number. It's clearly divisible by 10. Hold on. 2 times 5 times 7 times 7. 2 times 5 times 7 times 17 is 1190. Hold on a second. How do I figure this out? Oh, I get it. I get it. It's 30. 30 is the only one. These all could be. These are not necessarily factors of 1190 because again, it could be bigger than 1190. It's 30 because everyone else is a combination of one of these prime factors. Like this is 2 and 17. This is 5 and 5. That's okay. This is 2, 2, 5. Okay, we got 2s and 5s. This is 2 and 5. This one has a 3 in the mix. This is 2, 3, 5. There's no way because there's never going to be a 3 in there. If x is less than pi, sine of x equals 3 cosine of x, what's the value of x? Okay, I know how to do this. Sine x equals 3 cosine x. Divide by cosine of x. This is sine over cosine is tangent of x equals 3. Then I'll take arctangent of both sides. And I get x equals arctan of 3. 71. Okay, they obviously did this. Oh, it's in radians, so that's not a mistake. Arctan of 3. 1.25. Wait, 1.249. Let's keep going. All right, we're doing pretty good time-wise. And see now they might get harder. And slow me down. F of x equals this. What is the value of inverse f of 10? So first let's find the inverse function, and then let's plug it in 10. So inverse function is literally we switch the x and the y. So it's x equals 5 square root to y. And then I plug 10 in for the x. And then we have to solve for y. So then it's 10 equals 5 square root 2y. Divide both sides by 5. And I get 2 equals square root 2y. Square both sides. I get 4 equals 2y. Divide by 2. Divide by 2. Y equals 2. The Fibonacci sequence can be defined recursively as this, this, and then it's this plus this. Yeah. So the Fibonacci sequence is 1, 1, 2. Let's just do it. And then the next one is 3. It's the sum of these two. The next one is the sum of those two, 5. So we'll just find the 10th term like this. The next one is 8. That's the 6th term. Next one is 13. That's the 7th term. Next one is 13 plus 8 is 21. That's the 8th term. 1, 2, 3, 4, 5, 6, 7, 8. 9th term is 21 plus 13, which is 34. 10th term is 34 plus 21, which is 55. If f(x) equals this, which of the following statements are true? Function is... I'm just going to graph it. I'm not even going to think about it. X cubed minus 4x squared minus 3x plus 2. Okay, let's see. And then we want to know when x is greater than 3. Here's 3. It says increasing. It's greater than or equal to 3. I agree with that. Because if you look here at 3, it's going up and it's not going to come back down, right? It's going to go boom forever. So I'm saying that one's okay. The equation f of x equals 0 has two normal solutions. Non-real solutions. Well, it's got 3 solutions total. I disagree with that. They're all real. Wait. Yeah, they're all real. -1, 0.438, and 4.562. That one's out. And then f of x is greater than or equal to -16 for all x is greater than 0. Here's 0. And the lowest point we already saw was -16, so I agree with that. So 1 and 3, done. Graphing calculator, and that's it. Next, portions of the graphs f and g are shown above. Which of the following could be a portion of the graph f times g? Okay, so here's how I'm going to do it. Like this, like this. Okay, so they're opposite signs here. You see this? So positive times a negative is going to be negative. And then, of course, it's like approaching 0. You see? So it's like probably getting bigger, bigger, bigger. And then it hits 0 right here. And then again, they're opposite sides. So it's again going to bounce back and go negative, 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 negative like that. So not this one, even though it's all negative. This one looks like it's probably A. Nope. D and C, I already said they can't be positive because it said multiplying, right? Yeah. And then the same objection with E. So I know it's got to be A. 42. The set of all real numbers x such that blank equals this consists of nothing. This is absolute. This is the same as absolute value, so this should always be. No, wait, hold on. Negative numbers, non-positive real numbers. Because then if x is -4, I plug -4 in and you square it 16 square root 4, and then -4 is also 4. So non-positive real numbers. Yeah, because that includes 0. So I would say that's right. The triangle shown above, sine of A is, okay, we're using the law of sines. So sine of A over alpha, but I'll just say A over 4. It's sine of this over its opposite side equals sine of 30 over 3. Cross multiply. 4 sine of 30 equals 3 sine of alpha, or A. And then we divide both sides by 3. No, sorry. Divide both sides by 3. So then it's 4 sine of 30. 4 sine of 30 equals this divided by 3. is this, and then that equals, so it's like 2/3 is what it was, equals sine of A, and then we take arc sine of both of that side. So arc sine of 2/3 41.81. Oh, no, we just wanted sine of A. I already got it. It's 2/3. 2/3. Forget that. We just wanted sine of A, and it was 2/3. Okay, the length, width, and height of a rectangular solid are... Okay, I always like to draw it out right off the bat. To be honest, the time actually is going really well. Like this is... I'm sure I have way more time than I need to finish this. Because to have 20 minutes to do the last 7 problems is like pretty great, I think. Okay, so we've got 8, 4, and 1 respectively. Length, width, and height. What is the length of the longest line segment whose endpoints are the 2 vertices? Okay, so watch this. I've done problems like this before on the real SAT. So basically we're going from, like, let's say this point up to this point. So the way we're going to calculate is first I'm going to calculate this line from here to here. Okay? That's like a little triangle, so we can use Pythagorean's theorem. 4 squared plus 8 squared equals that squared. So 4 squared plus 8 squared equals, let's call it c squared. That's 16 plus 64, which is 80, equals c squared. So we take the square root. So square root, I'm going to call this line, I'm just going to call square root of 80. I'm not going to reduce it, doesn't matter. Then I'm going to put this one in red. Then we can now calculate this, because now we got a triangle, and you see that new triangle, and it's a right triangle, by the way. So we got a side of 1, 80, and then whatever the red is. So we'll call this C now, and I'll change back to black. So we got 1 squared plus square root of 80 squared equals C squared. That's 1 plus 80 equals C squared. That's 81 equals C squared. And of course, square root, C equals 9. All right, next. Log A equals, and log blank, then log A, 45. Wait, hold on. No, wait, I have to use my logarithm rules. Oh, I know what to do. It's this. Wait, hold on. Oh, yeah, here we go. This is like this, log of A of 3 plus log of A of 3 plus log of A of 5. Here's why. Okay, this means that when my logarithm rules, if I'm adding and I have the same A's, we just multiply these guys. So this is the same as log of A of 3 times 5, which that is 45. 3 times 3 is 9 times 5 is 45. So if this is the same as log of 45, then, well, since log of A is x, and this is x, and this is y, we have 2x plus y. I'm pretty sure that's correct. We could test this. We could test this how? We could test this by saying, forget about A, we'll just make it base 10. Log of 3 plus log of 3 plus log of 5 equals log of 45, so watch. I want to make sure I'm not mixing up the logarithm rule, so I'll double check. Equals that, and then we'll take log of 45. So remember, it's 1.6532. Yep, I am happy with that now. Sine of theta equals t, then for all theta in the interval, this tangent. Oh yeah, I know how to. Okay, so check this out. We're going to draw a triangle whenever we get something crazy like this. I'm going to call this theta. I'm going to make a right triangle. It's saying sine of theta is t. Sine is opposite. We're going to call this tangent. And we're going to call this, if sine of theta tangent over hypotenuse, well, maybe then the hypotenuse is 1. I'm just making this up. I could have also made this t squared and this side t. It doesn't matter. But I'm going to say this is t over 1 is t. So sine of theta is t. Well, then what's this side? This side can be derived from the following equation. X squared plus t squared, if I'm going to call this x, equals 1 squared. Then I isolate by saying 1 squared is just 1, 1 minus t squared, and I take the square root. And then this side is therefore 1 minus t squared. Now I can take tangent of theta. You see how clearly I'm on the right track. Tangent of theta is opposite over adjacent. It's t over square root of 1 minus t squared. Yeah, all right, good. Which of the following shifts of the graph y equals x squared will result in the of y equals x squared minus 2x plus k, where k is greater than 2. All right, I'm going to put this into, vertex form. So I'm going to say this is y equals x squared minus 2x. Then we take half of that, which is negative 1, and square it, which is 1 plus k. But if I'm adding a 1 here, I have to subtract a 1 to balance it out. But then I factor this side. Y equals x minus 1 squared. That's this factored, right? Because x minus 1 times x minus 1 gives me this, plus k minus 1. Now I can see the vertex. The vertex is at 1 comma k minus 1. The vertex. This is why we call it vertex form, because whatever x is subtracting, that's the vertex x value, and this is the y value. And the original vertex here is at 0, 0. So what's happened? It's shifted to the right by 1. So this is out, this is out, this is out. And up by k minus 1, which is e. Okay, next, so vertex form important. Next, if the height of a right circular cone, let's draw it out so we remember what a cone is. If the height of a right circular cone is decreased by 8%, so it's now 92% of its original, so it's now 0.92 h, by what percent must the radius of the base be decreased? So the volume of the cone is decreased by 0.1. Hold on. So the volume needs to be wait 0.85 v. Oh, I get it. Okay, hold on. So first of all, the volume is 1/3 pi r squared times h. Let's just pretend the volume's 1, all right? So I'm just going to say 1 equals 1/3. No, I got an easier way. Let's pretend the volume's pi. I can make that up. It doesn't matter. Pi equals 1/3 pi r squared h. Now I'm saying, is this the right way to do it? Hold on. 1/3. Okay, no. I got a better way. So we're saying that the original volume is now going to be 0.85. So 0.85 times 1/3 pi r squared h equals I'm a little confused here. Okay, I think then I'm going to set this equal to, I know what to do, sort of, but I could probably plug and chug and figure this out. But hold on, pi, and we need to know r squared. Oh, I know, I'll set a c value. Here we go. Pi times cr squared, and that's my percentage, that's what we're solving for, times h, and then h is decreased by 0.8, so it's 0.92 h. Okay. Now I've got these two, and now I got to solve for c. Oh, wait, this whole thing is squared. I put the square in the wrong spot. So now I can solve, and I can say, hold on, 0.85, I'll just put it over 3 pi r squared h equals 0.92 over 3 pi c squared r squared h. So I'm squaring that. And then now we can cancel out the h's. We can cancel out the r squared. Cancel out the pi. So then it's 0.85 over 3 equals 0.92 over 3. And I'll put the c squared on top. And then we cross multiply. 3 times 0.92 is 2.76. So we got 2.76 c squared equals 3 times 0.85. 2.55. Divide by 2.76. C squared equals 2.55 divided by 2.76. Equals 0.9239. But then I need to take the square root of that because that was c. So I take the square root of second answer, and it's 0.9612. Which means it's 96% of what it was, which means it's about a 4% decrease. By what percent? I should say approximate, right? But I think that's close enough. I think it didn't say approximately, it said by what percent, so that makes it a little suspicious, but I think that's right. Okay, matrix A has dimensions m by n. Matrix B has n by n. Matrix B has n by p, and where m, n, and p are distinct. Which of the following statements must be true? Product of BA does not exist. So the number of rows. Shoot, I can't remember this. Hold on. Yeah, no. The rows has to equal the number of columns. And so it's always rows by columns. So BA does exist. Product of AB Oh, wait a minute. I'm sorry. The number of columns has to equal the number of rows. Because this. Because this could have also 2, 7, 6. This would be boom, 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 and then it'd be and then boom, 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 and then the final one would be 1 by 2. Two by 1. Oh wait, sorry, 1 by 2. Yeah, that's 1 by 3. So actually, BA does not exist. Hold on, and then let's make sure. So this is rows is 1, columns is 3, rows is 3, columns is 2. So BA, this one times this one, would not work. So that is true. The product of AB exists and has dimensions m by p. Hold on. 1 row, which is m, and 2 columns, it's 2, not 3. I think this is right, 1 and 2. Man, matrix multiplication, I get a little shooken up on it because I don't do it very much. But I think that's right. We'll check the answers. If it's wrong, I just mix something up, and it doesn't mean it's hard for you necessarily. You just have to practice. I would just practice some matrix multiplication. You'll have it down. If W is the complex number shown in the figure above, which of the following points could be negative IW? Hold on. Okay, so let's pretend, I'm just going to make this up. This would be, let's make this, that's negative 1. This is negative, let's say 1.5. So W would be let's say 2i. Let's just make it 3i. Okay, make it simple. So this is negative 1.5 plus 3i. So if I'm multiplying it by negative I, right? Negative I. It would be positive 1.5i minus 3i squared, which is, I squared is negative 1, so it's positive 3 plus 1.5i. So 1, let's say 2, so it's 3. I guess it's A. Okay, that is it. We got 6 minutes to spare. I'm not going to check any of my work. I'm just going to stop the timer and go ahead and correct it and see what we got. Just make sure I didn't miss anything. I'm pretty sure I got everything. That looks good. That looks good. All right. Here we go. Let me just get the book. All right, we got DC, DAC. DC, DA. C, 6 is ECDDB. DDB, yep. DDB. Then I've got ECBDA. Then I've got 16, which BBADD. Oh no, it's B. Oh man, terrible mistake. Okay, so check it out. This is where I made a mistake. What am I plotted the points wrong. Okay, so this is 0, 0, and 0, 4 is up here. This is the y. I totally missed that. So of course it's y equals 2. What am I thinking? That was a huge mistake. Really bad one because that's an early problem that was pretty easy. I literally just drew it wrong. So if you caught that while you were working along with me, kudos. All right, A, D, and D. All right, 21 is CCCBE. CBE. And then 26 is DBCED. CED. 31 is CDDCB. CB. 36 is DECCD. 36 is DECCD. Yep. D. 41 is ABCBA. A, B, C, B, A. 46, BEADA. B-E-A-D. Yes, that's the matrix one I was worried about, and I got that one right too. All right, baller. So I got one wrong. Let me just check the curve. Like, the curve is pretty crazy on these tests. So usually you can get like 6, maybe 8 wrong, and you still get a 800. So I'm pretty sure it's an 800, but... Where's the curve? Here we go. Yeah, so you can get a 44, which is 6 wrong, and still get an 800 on this test, which is really cool, I think, which is really nice about it. All right, let me quickly see. I got to actually run pretty soon here, but let's see if I got any questions. Never been called Papa Kapadia. Yeah, what's up? Why do we leave 80 in square root form? Because it doesn't really matter. I knew I was going to put it into Pythagorean's theorem again and square it again. So it's just a waste of time. But what does it become, right? It becomes 4 root 5. If you would have done that, it's fine. Will the stream be up on your channel? Yeah, always, dude. These streams always go up on the channel, so you can check it later. It looks like it's it, so a lot of people weren't able to join. Hopefully you guys can watch this on the replay. Again, if you're watching now and you like what you saw, please click that like button. It really helps out the channel, really helps spread the word to more people who are trying to do their best on standardized tests and really grasp and embrace mathematics. Thank you guys so much for joining, and I'll see you all next time. Take it easy.